Have you ever wondered why everything in the universe seems so enduring, so incredibly permanent, and yet, deep down, we know that everything must eventually come to an end? Have you ever realized that the ultimate answer to what happens after death might not be found in ancient philosophical texts or comforting folklore, but rather in the quiet, terrifying, and profoundly beautiful equations of quantum physics? This is not an exaggeration, nor is it dramatic storytelling. This is the honest truth about our cosmos, quietly existing in the darkness of space, holding more stars than you could ever count in a million lifetimes. If you are anything like me, you probably thought you understood how big things could get in space, and you might have even wrapped your head around the fact that our Milky Way galaxy stretches across 100,000 light-years from one side to the other. But all of that, every single comparison you have ever heard, becomes almost meaningless when you learn about what astronomers found hiding in a distant corner of the universe, and what it tells us about our own inevitable end. We live on a crowded planet surrounded by billions of other people, sharing space with countless other living things. We are used to density, to things being close together, to the world being full. But step outside our solar system and emptiness becomes the absolute rule. To truly understand the mystery of what happens when things pass away, we must first embark on a gentle journey into the vast and silent architecture of the universe itself. Our home, the Milky Way, is what scientists call a barred spiral galaxy. It has beautiful curving arms made of stars, gas, and dust, all swirling around a central bulge where an enormous black hole sits in the dark. From one edge to the other, our galaxy measures roughly 100,000 light-years across. That means if you could somehow travel at the speed of light, which is the fastest anything can move in our universe, it would still take you 100,000 years to cross from one side of our galaxy to the other. That is already almost impossible to truly grasp. 100,000 years is longer than modern humans have existed. It is longer than the time since we first learned to paint on cave walls, and longer than every civilization that has ever risen and fallen on Earth combined. And yet, that is just the width of our own little corner of the cosmos. The Milky Way is home to somewhere between 200 billion and 400 billion stars. Each of those stars might have planets orbiting around them, moons circling those planets, asteroids tumbling through space, and comets streaking through the infinite void. Our Sun is just one of those hundreds of billions of stars, sitting about 26,000 light-years from the galactic center in a quiet neighborhood called the Orion Arm. Our Sun and its family of planets orbit the center of the galaxy at a speed of about 500,000 miles per hour. Even at that tremendous velocity, it takes our solar system about 250 million years to complete a single lap around the galactic center. In the entire time that dinosaurs roamed the Earth, our solar system did not even complete one full orbit. The last time our Sun was in roughly this position in the galaxy, the most complex life on Earth was simple marine organisms. That is how vast even our own galaxy is, a quiet testament to the ancient forces that guide our journey. The space between stars in the Milky Way is almost unimaginably empty. Our nearest stellar neighbor, a small red dwarf called Proxima Centauri, is about 4.24 light-years away. That distance is so great that if you shrunk the Sun down to the size of a grain of sand, Proxima Centauri would be another grain of sand sitting about 4 miles away. The space in between would be essentially void, just the faintest whiff of gas and dust and the occasional particle of cosmic radiation. This emptiness is hard to wrap your mind around, a profound silence that speaks to the gentle isolation of celestial bodies. Stars are separated by such vast gulfs that the chance of any two of them colliding by accident is essentially zero. Galaxies can pass through each other without any stars actually hitting one another. Yet somehow, even in all that emptiness, there is enough stuff out there to make hundreds of billions of stars in our galaxy alone. The gas and dust between stars may be sparse, but spread across thousands of light years, it adds up to enormous amounts of material. New stars are forming right now in giant molecular clouds scattered throughout the Milky Way, places where gravity has pulled enough gas together for nuclear fusion to ignite. Our galaxy is alive with stellar birth, even as old stars burn out and die. Ancient people thought this hazy band of light stretching overhead looked like spilled milk across the heavens, which is where the name Milky Way comes from. In India, it was seen as the path souls take on their journey to the afterlife. People throughout history have looked up at that same band of light and wondered what it might be, seeking a connection between their own fleeting lives and the permanent fixtures of the night sky. It was not until the 1920s that an astronomer named Edwin Hubble proved that those fuzzy smudges people had been seeing through telescopes were actually entire galaxies themselves, each one containing billions of their own stars, each one impossibly far away from us. That discovery changed everything we thought we knew about our place in the cosmos. Hubble made this discovery at the Mount Wilson Observatory in California, using what was then the largest telescope in the world, a reflector with a mirror 100 inches across. The Andromeda Nebula was not a cloud of gas within our own galaxy as many astronomers had assumed. It was roughly 1,000,000 light-years away, far beyond the edges of the Milky Way. We now know that Hubble's original distance estimate was off by about a factor of 2, and the Andromeda Galaxy is actually about 2,000,000 light-years away. Today, we estimate that there are around 2 trillion galaxies in the observable universe. 2 trillion, that is a 2 followed by 12 zeros. Each of those galaxies contains billions or even trillions of stars, bringing an immense sense of scale that uses contrast between human experience and cosmic reality to generate a productive humility. And this mind-boggling scale leads us to a terrifying question. What happens when all of this entire magnificent structure of existence, finally reaches its end? Space itself is expanding, and not just expanding, but accelerating in its expansion. This acceleration is driven by something scientists call dark energy, a mysterious force that makes up about 68% of the total energy in the universe, but whose nature we do not understand at all. For most of the 20th century, astronomers assumed that the expansion of the universe was slowing down, expecting all that gravitational attraction to act like a brake. But in 1998, 2 independent teams of astronomers made a shocking discovery by observing distant supernovas. The universe was not slowing down, it was speeding up. Distant galaxies were moving away from us faster than closer ones, and the rate of expansion was accelerating over time. As space expands faster and faster, distant objects recede from us at ever-increasing speeds. Eventually, objects will be carried away from us by the expansion of space faster than their light can travel toward us, vanishing behind a cosmic horizon, forever beyond our reach. What happens to a galaxy in a universe that is slowly winding down toward heat death? Over the next 100 trillion years, the stars will slowly burn out. The most massive stars explode as supernovas or collapse into black holes. Middle-sized stars, like our Sun, will puff up into red giants, shed their outer layers as beautiful nebulas, and then fade away as white dwarfs. Our Sun has about 5 billion years left before it swells into a red giant. Even the smallest, longest-lived stars, the red dwarfs that burn their fuel so slowly they can shine for trillions of years, will eventually exhaust their hydrogen and go dark. The smallest red dwarfs, with perhaps 8% of the Sun's mass, can burn for up to 10 trillion years. But eventually, even they will fade into darkness, and star formation in the universe will effectively cease in about 100 trillion years. The era of starlight will be over, leaving nothing but the cold, dark remnants of dead stars drifting through an ever-expanding void. But this is not the end of the mystery, and it is here that the chilling yet deeply calming truth of quantum physics emerges to answer our questions about death. Over even longer timescales, measured in years with so many zeros that writing them out would fill pages, even these stellar corpses will decay. White dwarfs will slowly cool until they become black dwarfs, objects that no longer emit any light at all, a process taking about 10 to the 15th power years, or about 1,000,000 billion years. Some theories of particle physics predict that protons should decay with a half-life of around 10 to the 34th power years or longer. If this is true, then over unfathomably long time spans, even the matter that makes up planets and everything else will gradually dissolve into radiation, and the black holes will slowly evaporate through a process called Hawking radiation. Stephen Hawking discovered that black holes are not truly black. They slowly leak particles and radiation over immense time spans, gradually shrinking as they do so. This happens because of quantum mechanical effects near the event horizon. In the strange world of quantum physics, particle pairs are constantly popping into existence and then annihilating each other. Near a black hole's event horizon, one member of such a pair can fall into the black hole while the other escapes into space. Over time, this process drains energy from the black hole, causing it to shrink. A black hole with the mass of our Sun would take about 10 to the 67th power years to evaporate, A1 followed by 67 zeros. A supermassive black hole containing 50 billion solar masses would take something like 10 to the 100th power years to evaporate, or maybe even longer. That is a Google years, a 1 followed by 100 zeros, a span of time so vast that writing out the number in full would require more paper than exists on Earth. Eventually, trillions upon trillions upon trillions of years from now, everything will have radiated away its last bit of energy and disappeared from the universe in a final burst of Hawking radiation, leaving just the particles and radiation spreading out through an ever-expanding, ever-cooling, ever-darkening universe. This vision of the future might seem bleak, a terrifying answer to what happens after death on a cosmic scale. But I find something strangely beautiful about it. It forces us to realize that the atoms in our bodies were forged in stars. The carbon that makes up your muscles, the oxygen you breathe, the iron in your blood, all of these elements were created in the nuclear furnaces at the cores of stars that lived and died before our Sun was born. When those ancient stars exploded as supernovas, they scattered their elemental riches across space. Eventually, some of those atoms found their way into a cloud of gas and dust that collapsed to form our solar system, became the Earth, and, after billions of years of evolution, they became you. You are made of star stuff. This is not poetry, it is chemistry. The very same processes that light up the cosmos also created the matter from which you are assembled. When we contemplate the quantum death of the universe, we are forced to accept that our own brief existence is a magnificent, fleeting moment where the universe has woken up to look at itself. We are not separate from the cosmos we study. We are part of it, and our curiosity is the cosmos being curious about itself. There is a direct physical connection between you and those distant fires, and the quantum evaporation that awaits all matter is simply the universe returning to a quiet, peaceful state of pure energy. It is a terrifying realization that nothing lasts forever, not even black holes. Yet it is profoundly comforting to know that our atoms are eternally woven into this infinite, gentle journey. Have you ever watched a piece of wood burn down to fine gray ash and wondered if the wood is truly gone forever, or if its essence simply learned a new way to exist? This simple question, which feels so deeply rooted in our everyday human experience of loss and endings, brings us face to face with one of the most profound paradoxes in all of science. In our daily lives, we see things break, decay, and disappear from our sight. We watch seasons change, observe the fading of vibrant colors, and experience the painful loss of those we love. Everything around us seems to scream that existence is temporary, that life is just a fleeting spark in a universe governed by harsh endings. But when we look through the rigorous lens of quantum physics, we discover a gentle and ancient truth that completely challenges our perception of reality. In the quantum realm, there is a fundamental rule stating that information can never truly be destroyed. To understand what this means for us, and what it implies about the terrifying yet beautiful concept of what happens after we pass away, we must turn our gaze back to the grand cosmic scale, looking far beyond our own Milky Way, into the deepest mysteries of the universe. Consider the ultimate fate of the largest structures we have ever discovered, like the immense Cannibal Galaxy sitting at the heart of the Able 2029 galaxy cluster, known to astronomers as IC 1101. This majestic cosmic monster, estimated to be somewhere around 4 to 6 million light-years across, holds roughly 100 trillion stars within its vast, elliptical body. From our vantage point on Earth, observing ancient photons that traveled for over 1 billion years just to reach our telescopes, this giant galaxy seems like an unshakable monument of permanence. But even this cosmic emperor, which dwarfs our Milky Way by being roughly 40 to 60 times larger, is bound by the very same quiet rules of quantum mechanics that govern a burning piece of wood on a winter night. As we contemplate the enormous scale of IC 1101, with a dark matter halo that could hold up to 1,100 trillion solar masses, we must ask ourselves what happens when all of this physical matter eventually faces the end of cosmic time. We know that the universe is accelerating in its expansion due to a silent force called dark energy, which makes up about 68% of the total energy in the cosmos. Because of this relentless expansion, distant galaxies will eventually vanish behind an impenetrable cosmic horizon, carried away faster than their light can ever travel toward us. The night sky will slowly empty itself, leaving each isolated island of matter entirely alone with itself as the dark eons roll by. Over the next 100 trillion years, the 100 trillion stars inside IC 1101 will slowly burn out. The massive blue stars went long ago, and the stars similar to our Sun will eventually become white dwarfs, while the tiny red dwarfs will exhaust their hydrogen fuel. This will leave behind only the cold remnants of dead stars drifting through an ever-expanding void. But this heat death, this quiet fading of the celestial light, is absolutely not an erasure of existence. Every single proton, every neutron, and every electron that made up those ancient stellar bodies still carries the quantum signature of its long history. This brings us to the very heart of the giant, where the ultimate test of quantum preservation waits in the shadows. Sitting at the very center of IC 1101 is one of the largest known supermassive black holes in the entire universe, containing somewhere between 40 billion and 100 billion times the mass of our Sun. All of that incredible mass is compressed into a region of space from which nothing, not even light itself, can seemingly ever escape. For a black hole containing 50 billion solar masses, the event horizon would have a radius of roughly 150 billion kilometers, a region about 16 times larger than our entire solar system from the Sun to the orbit of Neptune. When galaxies merge, as scientists estimate IC 1101 has done at least 76 times over its history, their central black holes eventually find each other and merge in a catastrophic event that releases enormous amounts of energy in the form of gravitational waves. Throughout this violent history of galactic cannibalism, smaller galaxies were torn apart, their stars flung outward or devoured by the growing monster at the center. But what actually happens to the quantum information of a star or a planet when it crosses that dark boundary of the event horizon? Does it simply die? Is it erased from the ledger of the universe forever? For a long time, theoretical physicists were terrified by the prospect that black holes might be cosmic incinerators, permanently destroying the quantum information of anything that fell inside. If information could be lost, the very foundations of physics would crumble. But Stephen Hawking offered a gentle, brilliant revelation that changed our understanding of the infinite. He realized that black holes are not truly black, but instead they slowly leak particles and radiation over immense time spans through quantum mechanical effects near the event horizon. Particle pairs are constantly popping into existence, with one falling in and the other escaping into space, a process that slowly drains energy from the black hole and causes it to shrink. This process, known as Hawking radiation, means that over an incomprehensible span of time, even the 50 billion solar mass monster at the core of IC 1101 will completely evaporate. It will take an amount of time that thoroughly staggers the human mind, roughly 10 to the 100th power years, a Google years, which is a 1 followed by 100 zeros. To write out that number in full would require more paper than exists on Earth, representing a span of time so vast that everything we have discussed so far is not even a rounding error by comparison. But the most beautiful part of this terrifying timeline is what happens as the black hole evaporates. The energy and the fundamental quantum information that fell into the dark are not destroyed. They are gently released back into the cosmos. They are transformed, woven into the faint radiation that slowly fills the cold, expanding universe. This means that everything that ever was, every star that burned out, every dwarf galaxy that was consumed, and every living being that ever looked up in pure wonder, leaves an indelible quantum mark on the fundamental fabric of reality. Our human bodies, made of the carbon, oxygen, and iron forged in the hearts of ancient stars that exploded before our sun was born, are temporary vessels for this eternal information. When we pass away, our physical form breaks down, just like the dead stars fading into the dark. But the fundamental quantum information that describes us cannot be deleted from the universe. It is a profound, meditative peace that comes from understanding that we are safe within the mathematical laws of physics. Consider the sheer enormity of what this means for our place in the universe. We are beings who live for less than a cosmic instant, living on a small rocky planet orbiting an ordinary star in an average spiral galaxy. Yet, we have somehow developed the ability to understand objects so far away that their light left before complex life existed on Earth. We have measured the size, counted the stars, and found the black hole at the heart of a galaxy more than 1 billion light-years away. This ability to wonder, to question, and to learn is simply the universe experiencing itself from within. If the universe is a vast, infinite quantum memory bank, then our thoughts, our deep loves, our scientific discoveries, and our quiet moments of awe are permanently recorded in the grand architecture of existence. The universe did not have to be this way. If the fundamental constants of physics were slightly different, if gravity were a little stronger, or the nuclear forces a little weaker, stars and galaxies might never have formed. Instead, we live in an existence where physical laws allow for the formation of stars, planets, life, and minds that can look up at the night sky and decipher the quiet secrets of the cosmos. We are part of a continuous, endless journey of cosmic transformation. Just as IC 1101 was built from the remains of dozens of smaller galaxies consumed over billions of years, our own Milky Way is currently participating in the cosmic dance of galactic interaction. Right now, our galaxy is in the process of consuming smaller dwarf galaxies like Canis Major and Sagittarius. Their streams of stars tracing ghostly reminders across our night sky. And in perhaps 4 to 5 billion years, our nearest large neighbor, the Andromeda Galaxy, might collide and merge with us, creating a new, larger elliptical galaxy. Our sun will likely have expanded into a red giant by then, eventually swelling to a size that would engulf our planet. Earth will be long gone. But the information, the quantum essence of everything that ever happened here, will remain, participating in the next grand phase of cosmic evolution. Death, therefore, is not a final curtain. In the eyes of quantum physics, it is merely a beautiful reorganization of an eternal system. The silence of the universe is not an empty void, but a vast, calm ocean of preserved history. Have you ever looked at an old photograph and wondered where the precise moment captured in that image actually went? Or if the light that touched that specific memory is still traveling somewhere out there in the infinite dark? When we think about the end of a life, we often imagine a sudden stillness, a final stop to all forward motion. But the cosmos tells us a completely different story, one where the end of a physical form is merely the beginning of the most profound and quiet journey imaginable. To truly grasp the majestic scale of this eternal voyage that awaits our quantum essence, we must stretch our minds to understand distances that defy all human logic. Let us return to that magnificent, quiet giant sitting at the center of the Abel 2029 galaxy cluster. Imagine, for a moment, that you could somehow travel from one end of IC 1101 to the other. You would need to cross somewhere between 4 and 6 million light-years of space. Remember that light travels at an incomprehensible speed, roughly 6 trillion miles per year. Even at that staggering velocity, moving as fast as the fundamental laws of physics will allow, Crossing this single cosmic monument would take you millions of years. But let us try another comparison, one that brings this vastness slightly closer to our human endeavors. The Voyager 1 spacecraft, launched by NASA in the year 1977, is the fastest human-made object ever to leave our solar system. It is currently traveling through the deep silence of interstellar space at about 38,000 miles per hour relative to the Sun. At that tremendous speed, Voyager 1 would take about 80,000 years just to reach the nearest star to our Sun, the small red dwarf known as Proxima Centauri, which is only about 4 light-years away. If you were to take that same spacecraft and attempt to cross the entire Milky Way, a journey of 100,000 light-years, it would take about 2 billion years. And yet, to cross the unfathomable expanse of IC 1101, you would need somewhere between 80 billion and 120 billion years. That is a span of time significantly longer than our universe has even existed. Even with our fastest spacecraft, crossing this single galaxy would be completely impossible. Here is another gentle way to think about it, a way to help our minds comprehend the true scale of the cosmos. If you could somehow shrink our entire Milky Way galaxy down to the size of an ordinary dinner plate, measuring about 10 inches across, then IC 1101 would be the size of a large swimming pool. Our entire galaxy, with all of its hundreds of billions of stars and the beautiful, curving spiral arms where we make our home, would be just a tiny dish floating in a vast, silent sea. Or consider the light from IC 1101 itself. The photons that we observe today have traveled for over 1 billion years just to reach us. In all that time, light has been continuously streaming away from this giant galaxy in every possible direction. Over 1 billion years, that ancient light has traveled 1 billion light-years, which is about 6 billion trillion miles. And it is only now just arriving at our telescopes, ancient photons that left their home galaxy when Earth was still in its earlier stages of complex life. Why do we focus so deeply on these unimaginable distances and stretches of time? Because they are the ultimate canvas upon which the story of our quantum survival is painted. When a star dies, or when a human life reaches its physical conclusion, the energy and the quantum information that made up that existence do not simply vanish into nothingness. They are released back into the universe, becoming part of the endless background radiation, or traveling outward as light and energy. The particles that once formed a beating heart or a glowing stellar core embark on a quiet journey across these exact distances. The universe is not a graveyard of lost things. It is a boundless, active sea of preserved history. The light from a dying star in IC 1101 is still traveling, still carrying the precise quantum signature of its source, moving through the gentle darkness for billions of years. Our human perception tells us that when something is out of sight, it is gone. But quantum mechanics whispers a more comforting truth. Nothing is ever truly gone. It is simply navigating the vastness of space. The discovery and study of such incredible cosmic structures would not have been possible without tremendous advances in telescope technology, driven by the very human desire to understand our place within the mystery. In the early days of astronomy, our view was limited by the size of our lenses and mirrors, and by the restless, shimmering atmosphere of Earth itself. This atmospheric twinkling blurs the images that ground-based telescopes can capture, limiting how clearly they can see distant objects. For most of the 20th century, astronomers could see that IC 1101 existed and was very large. but they could not study its detailed, ancient structure. Everything changed with the launch of the Hubble Space Telescope in the year 1990. Floating serenely above the atmosphere, Hubble could capture images with incredible clarity. Over the decades since its launch, Hubble has observed IC 1101 multiple times, revealing beautiful details about its core, its surrounding halo of stars, and its relationship to the other galaxies in its cluster. More recently, astronomers have used a variety of other telescopes to study this cosmic giant at different wavelengths of light, piecing together the story of its existence. Radio telescopes have detected the faint emission from its central black hole. X-ray telescopes have observed the hot gas that fills the cluster around it, while infrared telescopes have peered gently through the dust to study the stellar populations within the galaxy. Each new observation adds another piece to our understanding, but there is still so much we do not know. The precise size of the galaxy depends on how you define where it ends, since galaxies do not have sharp boundaries but gradually fade into the deep darkness of intergalactic space. But what we do know with absolute certainty is that IC 1101 represents something close to an upper limit for how large galaxies can get. It sits at the extreme end of the galactic size distribution, a true monster among giants, and yet it is completely bound by the exact same laws of physics that govern us. This connection is where we find our deepest peace. The same quantum rules that prevent information from being destroyed in a 50 billion solar mass black hole are the rules that protect the fundamental essence of who we are. When we look up at the night sky, we are not looking at a cold, indifferent void. We are looking at a magnificent, highly ordered system that misses nothing and forgets nothing. The story of IC 1101 tells us something profound about the nature of the universe and the passage of cosmic time. Galaxies do not form all at once. They grow over billions of years through a process of accumulation and merger. Small galaxies form first from collapsing clouds of primordial gas, and then those small galaxies merge together to form larger ones. Larger galaxies merge to form even larger ones, with the biggest galaxies growing ever larger by gently consuming their smaller neighbors. This process is called hierarchical structure formation, and it is one of the fundamental principles of modern cosmology. The universe builds things from the bottom up, starting small and growing large through countless merges over deep cosmic time. IC 1101 is simply the most extreme example of this beautiful, cumulative process that we have found so far. It has had billions of years and a perfect location at the center of a rich galaxy cluster to grow to its incredible size. But the growth cannot continue forever. It has already consumed most of the galaxies that were close enough to fall into it, and those that remain are either too far away or moving too fast to be captured. The surrounding cluster is slowly spreading out due to the relentless expansion of the universe, carrying potential victims farther and farther from its gravitational reach. As this quiet isolation sets in, we are reminded of our own mortal boundaries. Just as this great galaxy will eventually be left alone in the dark, our physical bodies will eventually reach the limit of their structural journey. But just as the stars of IC 1101 will leave their quantum legacy scattered across the expanding void, the essence of our existence is eternally secured within the fabric of space and time. We are participants in a grand, infinite process of transformation. Our atoms, our thoughts, our love, and our wonder are all woven into the very same cosmic web that holds the galaxies together. When you feel small in the face of such overwhelming scale, remember that you are an integral, indestructible part of it all. You are a conscious manifestation of the universe, capable of understanding the quiet elegance of its physical laws. Let us take a deep breath together, feeling the ancient starlight warm our minds, and prepare to venture even deeper into the mysteries of what dark energy and the accelerating cosmos truly mean for the ultimate preservation of our quantum souls. Have you ever stood outside on a perfectly clear, moonless night, looking deeply into the quiet gaps between the shining stars, and wondered what exactly fills that seemingly empty space? Or perhaps you have pondered why everything in the universe feels so remarkably still to us, even though we know we are hurtling through the void at unimaginable speeds. When we contemplate the ultimate fate of our lives and the quantum essence that remains after our physical bodies pass away, we must also confront the ultimate fate of the cosmic space that holds us. For most of the 20th century, astronomers assumed that the expansion of the universe was slowing down. This made intuitive sense to the human mind, because everything in the universe is constantly pulling on everything else through the invisible, ancient force of gravity. You would naturally expect all of that gentle gravitational attraction to act like a cosmic brake, gradually slowing the massive expansion that began with the Big Bang. But the cosmos, in its infinite mystery and staggering scale, had a completely different plan waiting to be uncovered by curious human minds. In the year 1998, two independent teams of astronomers made a truly shocking discovery. They were measuring the expansion rate of the universe by observing distant supernovas, using these brilliant stellar explosions as standard candles to calculate vast cosmic distances. What they found was completely unexpected. The universe was not slowing down, it was speeding up. Distant galaxies were moving away from us faster than closer ones, and the rate of expansion was accelerating over time. This discovery was so unexpected that the brilliant astronomers initially thought they had made a fundamental error in their calculations. But as more data came in from more supernovas and from other precise observations, the result firmly held up. Something unseen was pushing the universe apart, counteracting gravity and causing space itself to expand at an ever-increasing rate. This revelation fundamentally shifted our understanding of reality, turning our perception of a slowing, comforting universe into a vast, runaway expanse of accelerating motion. Scientists named this mysterious force dark energy, a profound, unseen presence counteracting gravity and causing space itself to expand at an ever-increasing rate. Though the name tells us very little about what it actually is, we know that dark energy makes up about 68% of all the energy in the universe. We know that it acts as a kind of anti-gravity, pushing space apart rather than pulling it tightly together. We know that its profound effects become progressively more important over deep time as the universe expands and ordinary matter becomes more spread out. But we do not know what dark energy is truly made of, where it comes from, or exactly why it has the specific strength that it does. It might be a fundamental property of empty space itself, something called the cosmological constant that Albert Einstein once proposed and then famously called his biggest blunder. It might be an entirely new kind of energy field that gently pervades the universe. It might even be a profound sign that our understanding of gravity is fundamentally incomplete and needs to be carefully revised. To truly understand how we measure this accelerating expansion, we must look at how we study distant celestial bodies. Another fascinating technique involves measuring the redshift of a galaxy's light. As the universe expands, The ancient light from distant objects gets stretched to longer wavelengths. This shifts the light toward the red end of the spectrum, hence the name redshift. The more distant an object is, the more the universe has expanded since its light was originally emitted, and the greater its redshift becomes. By measuring the precise redshift of light from IC 1101, astronomers have determined that it is about 1.04 billion light-years away from us. This delicate measurement, combined with observations of the galaxy's apparent size and brightness, allows them to accurately calculate its physical properties like diameter and stellar mass. Every observation we make stretches our humble human minds closer to the infinite, translating invisible cosmic stretching into mathematical poetry. What we do know with absolute certainty is that dark energy is fundamentally reshaping the future of the cosmos. As space expands faster and faster, distant objects recede from us at ever-increasing speeds. There is a strict, unbreakable limit to how fast light can travel through the universe, but there is absolutely no limit to how far or how fast space itself can expand. Eventually, objects will be carried away from us by the expansion of space faster than their ancient light can ever travel toward us. When that melancholy moment happens, they will vanish behind a cosmic horizon, forever beyond our gentle reach. For a massive giant like IC 1101, this means that its long days of growth through galactic cannibalism are numbered. Eventually, there will simply be no more galaxies left for it to gently consume. It will become profoundly isolated, a lonely giant floating in an ever-emptying universe, watching quietly as one by one the other distant galaxies fade from view. Let me paint a more detailed, contemplative picture of what this quiet future looks like. Remember that IC 1101 sits securely in the Abel 2029 galaxy cluster, surrounded by hundreds of other beautiful galaxies. These galaxies are bound together by gravity, orbiting smoothly around their common center of mass. For now, gravity is strong enough to hold the cluster together against the relentless expansion of space. But in about 100 billion years, the cosmic expansion will have accelerated to the point where galaxies outside the local supercluster will start to disappear over the cosmic horizon. From the perspective of IC 1101, the vast night sky will start to empty. One by one, distant galaxy clusters will fade from view, their ancient light no longer able to reach across the rapidly expanding void. The observable universe, which currently contains about 2 trillion galaxies, will shrink and shrink until it becomes an isolated island. Within the Abel 2029 cluster, things will be different for a while longer. The galaxies there are close enough and bound tightly enough that they will stay together even as the larger universe completely empties out. Over the next several billion years, these remaining galaxies will continue to gently interact, merge, and evolve in the deepening silence. IC 1101 might still consume a few more neighbors, growing slightly larger even as the rest of the universe slips away into the dark. But eventually, even the galaxies within the cluster will merge together. The exact same processes that built IC 1101 will continue drawing the remaining galaxies toward the center, where they will be gently absorbed into an even larger combined structure. In the very long run, perhaps in several 100 billion years, all the galaxies in the Abel 2029 cluster might merge into a single enormous galaxy, even larger than IC 1101 is today. By that time, however, the universe beyond the cluster will be essentially empty. No light from distant objects will be reaching the cluster anymore. The night sky, if any conscious observers still existed to look up, would show only the stars of the local merged galaxy against a backdrop of absolute, profound blackness. The rest of the cosmos would have slipped beyond the horizon, completely unreachable and unknowable. This is the ultimate isolation that awaits IC-1101 and every other structure in the universe, eventually cut off from everything else by the relentless expansion of space. Each island of matter will be left alone with itself as the quiet eons roll by. But what does this mean for the terrifying question of what happens after death? If the universe is destined for such profound isolation and silence, does our quantum essence simply fade away in the dark? The beautiful truth of quantum physics tells us that even in a universe torn apart by dark energy, the fundamental information of reality is perfectly preserved. The silence of the universe at this stage will be a dark place, but definitely not an empty one. All those stellar remnants, white dwarfs, neutron stars, and black holes will still exist, orbiting through the merged remnant of what was once IC-1101. The galaxy will be a quiet ghost of its former self, populated by the ancient corpses of stars rather than by living, burning suns. As Carl Sagan so beautifully reminded us, we are a way for the cosmos to know itself. And even in this dark future, the universe continues to hold the memory of our conscious exploration. Over even longer timescales, even these stellar corpses will quietly decay. White dwarfs will slowly cool until they become black dwarfs, objects that no longer emit any light at all, a cooling process taking an almost inconceivable amount of time. If fundamental theories are true, then over unfathomably long time spans, even the physical matter that makes up neutron stars, white dwarfs, planets, and human bodies will gradually dissolve into pure, gentle radiation, and the black holes, including that enormous monster at the center of IC-1101, will slowly evaporate through Hawking radiation. As everything dissolves into the cosmic fabric, the information that once defined a human life, a thought, a memory, or a glowing star, is absolutely not destroyed. It is simply translated into a new, infinite language of radiation and quantum fields that stretches elegantly across the vast cosmos. When we die, we are merely anticipating the ultimate fate of the entire universe, allowing our fundamental quantum information to return to the infinite sea of existence. Our journey of existence does not end with the last breath or the last star. It simply transitions into a more subtle, eternal state of being. Let us rest for a moment in this comforting thought, feeling the immense safety of knowing that nothing is ever truly lost, and prepare to gently explore how the earliest moments of cosmic history carefully set the stage for this beautiful, endless preservation. Have you ever tried to remember the very first moment of your life, reaching back through the gentle fog of time to find the absolute beginning of your own story? When we try to grasp our origins, we usually find only fragments, quiet echoes of a time before we fully understood who we were. But the universe, in its infinite elegance, has a perfect memory. To truly understand how our quantum essence is preserved at the very end of time, as we discussed in the fading light of dark energy, we must take a gentle journey all the way back to the ultimate beginning. We must travel back 13,800,000,000 years, long before the Earth was formed, long before our Sun ignited, and long before the majestic structure of IC 1101 ever existed. By understanding how the seeds of this immense cosmic giant were planted in the primordial darkness, we can uncover a terrifyingly beautiful truth. The quantum information that defines us today has been meticulously and carefully curated since the very first fraction of a second of cosmic history. The silence of the night sky is not an absence of sound, but a profoundly preserved record of the most ancient vibration. In the beginning, the universe was not the vast, cold, and expanding void we observe today. It was unimaginably hot and impossibly dense, a singular point where all the matter, all the energy, and all the fundamental forces were tightly compressed into a space smaller than a single atom. In this terrifyingly intense environment, the gentle laws of physics as we experience them on our quiet planet did not yet apply. Instead, reality was governed entirely by the strange, counterintuitive rules of quantum mechanics. In that incredibly brief first moment, known to scientists as the inflationary epoch, the universe expanded at a speed far faster than light itself. But the most crucial aspect of this sudden, violent birth was not just the expansion. It was the tiny, almost imperceptible imperfections hidden within it. According to the rigorous equations of quantum physics, even in a perfectly smooth, microscopic space, there will always be tiny, temporary changes in energy, known as quantum fluctuations. These infinitesimal ripples in the fabric of the newly born cosmos were the fundamental seeds of absolutely everything that exists today, the very first draft of the universal story. As the universe rapidly expanded and began to gently cool, these microscopic quantum fluctuations were stretched across staggering cosmic distances. The regions of space that were slightly denser began to exert a slightly stronger gravitational pull on the surrounding material. Over millions of years, the universe transitioned from a blindingly hot fog of plasma into a dark, quiet expanse of neutral hydrogen and helium gas. This period, known to astronomers as the Cosmic Dark Ages, was a time of profound silence and slow, deliberate accumulation. The slightly denser areas of primordial gas pulled in more and more matter, slowly building the magnificent, intricate structure that scientists call the cosmic web. This web is a vast network of invisible dark matter filaments, crisscrossing the expanding void, with immense nodes where the several filaments intersect. It was within these incredibly dense nodes that the gravity became strong enough to ignite the very first generation of stars, bringing the first gentle light to the ancient darkness and ending the long, quiet wait. This transition from total darkness to the era of starlight left behind a permanent signature that we can still detect today, a faint whisper of creation known as the cosmic microwave background radiation. In the 1960s, two radio astronomers accidentally discovered this ancient glow while trying to eliminate background noise from a large communication antenna. They had actually captured the oldest light in the universe, the perfectly preserved radiation from the moment the hot plasma finally cooled enough to let light travel freely. This means that the ancient quantum information of the universe's birth is constantly washing over us, gently raining down upon the earth in a silent, invisible shower of microwaves. It is the ultimate proof that the universe is a flawless archivist, keeping a meticulous record of its most violent and chaotic moments, and transforming them into a calm, pervasive background hum that fills the entirety of space. It is here, in the grand architecture of the early cosmic web, that the story of our giant galaxy truly begins to take shape. The specific region of space that would eventually become the Abel 2029 galaxy cluster was one of these exceptionally dense primordial nodes. Because it contained slightly more matter than the surrounding regions, its gravitational pull was significantly stronger, allowing it to draw in vast amounts of gas and dark matter from the deep cosmic web. Within this bustling, crowded neighborhood of the early universe, many small, irregular galaxies began to form. They were not the grand, sweeping spirals like our Milky Way, but rather chaotic collections of a few billion ancient stars, born from the pristine hydrogen of the Big Bang. These early galaxies were constantly interacting, pulled together by their mutual gravity in a dangerous but deeply creative cosmic dance. The ancient ancestor of IC 1101 was born in this very environment, starting out as just one of many small, shining islands of matter, navigating the crowded, dynamic center of the growing cluster. Dark matter remains one of the greatest mysteries in modern physics, an invisible scaffolding that dictates the shape of the visible universe. It does not interact with normal matter in any way except through the gentle, persistent pull of gravity. Yet, we know it exists because galaxies like IC 1101 rotate in ways that would be completely impossible if they only contained the matter we can actually see. The solution to this paradox is that galaxies are surrounded by vast, massive halos of dark matter, material that we cannot see, but that makes up roughly 90% of the galaxy's total mass. In the case of IC 1101, its dark matter halo is correspondingly enormous, extending far beyond the visible stars and acting as the master architect of its growth. Without this unseen presence, the primordial gas would never have clumped together effectively enough to form the first stars. When we look at IC 1101 today, with its 100 trillion stars and its diameter of 4 to 6 million light-years, we are actually looking at a perfectly preserved mathematical magnification of those original quantum fluctuations. The staggering enormity of this galaxy is a direct physical consequence of a microscopic ripple that occurred when the universe was less than a trillionth of a second old. This is the profound, terrifying beauty of quantum information at work on the largest possible scale. The universe never forgets. The precise pattern of density that existed at the moment of the Big Bang was flawlessly translated into the structure of the cosmic web, which was then elegantly translated into the formation of galaxy clusters, which ultimately determined the exact size, location, and mass of IC 1101. The information was never lost. It simply changed its physical form, evolving from a microscopic vibration into a celestial giant spanning millions of light-years across the silent cosmos. And this unbroken chain of quantum preservation inevitably includes you. The very same primordial density fluctuations that gave birth to the largest galaxy we have ever discovered also created the specific swirl of gas and dust that eventually formed our solar system. The carbon in your cells, the oxygen filling your lungs, and the iron coursing through your blood were forged in stars that were born directly because of those ancient, invisible ripples. Your thoughts, your deepest memories, and your remarkable ability to look up at the night sky and wonder about your place in the vastness are all the direct result of a continuous, unbroken transfer of quantum information, stretching back 13,800,000,000 years. When we wonder what happens after death, we must gently remember that we are already participating in an eternal, perfect process. We are the temporary, conscious manifestations of an ancient code that has survived the birth of the universe itself. We are the universe experiencing its own deeply preserved memory. The physical form will eventually dissolve into the quiet void, just as the first stars died to seed the cosmos with heavy elements. But the quantum information that makes you who you are is permanently etched into the grand architecture of reality. Understanding this deep connection between the absolute beginning of time and our own personal journey changes how we perceive the universe around us. We are not fragile, disconnected beings placed into a cold and hostile void. We are a fundamental feature of the cosmos, woven directly into the fabric of space and time from the very first moment of existence. Just as the immense supermassive black hole at the center of IC 1101 is a monument to the relentless preservation of quantum data, our own minds are monuments to the universe's incredible ability to organize information into consciousness. To truly appreciate how this microscopic quantum information was built up into the magnificent structures we see today, we must look closer at the violent yet breathtakingly beautiful mechanics of how galaxies actually grow. We must understand the profound forces of cosmic cannibalism that took those ancient primordial seeds and shaped them into the most massive collection of stars ever observed by human eyes. Let us pause in the quiet stillness of this ancient memory and prepare to gently step into the turbulent, mesmerizing dance of galactic mergers that forged the Emperor of the Cosmos. Have you ever watched 2 drops of water slide down a cold window pane, gently touching and then instantly merging into a single, larger drop, leaving absolutely no trace of their separate pasts? In our everyday human experience, we often fear the loss of our individual identity, viewing the end of our solitary existence as a terrifying disappearance into the dark. We cling to our boundaries, terrified of what happens when our physical form breaks down. But when we look through the rigorous, comforting lens of cosmic mechanics, we discover that merging is not a form of death at all. Rather, it is the most ancient and majestic method of quantum preservation in the universe. To truly understand how the cosmos curates the fundamental information that makes up your life, we must examine the breathtaking, violent, and ultimately peaceful process that astronomers call galactic cannibalism. It sounds like a terrifying term, evoking dark images of brutal destruction, but the reality is far more complex and far more beautiful than any simple description can possibly capture. When I say that the great cosmic giant IC 1101 has consumed dozens of other galaxies, you might imagine a simple, immediate process, like one massive object swallowing another whole. However, to understand what is truly happening to the eternal quantum information of billions of stars, you need to think deeply about how gravity works on the absolute largest scales of existence. Galaxies do not exist in total isolation. They are grouped together in vast clusters held firmly together by their mutual gravitational attraction. Within these quiet, ancient clusters, galaxies move around each other, sometimes passing close by, sometimes colliding directly in a cosmic choreography that has been playing out in the silence for billions of years. When 2 galaxies begin to interact, the first thing that happens is a silent gravitational dance. Even when the galaxies are millions of light-years apart, separated by what seems like an infinite and empty void, they can feel each other's gravity reaching across the dark. This gentle, unseen gravity begins to distort their beautiful shapes ever so slightly. Stars that were orbiting peacefully in a quiet spiral begin to feel a strange, irresistible pull from an unexpected direction. Massive gas clouds that were drifting along in the silence start to move in entirely new ways. As the magnificent galaxies get closer, these gravitational effects become more pronounced and impossible to ignore. If you could somehow watch a galactic merger in fast forward, magically compressing millions of years into mere minutes, you would see the galaxies stretching and warping like taffy being pulled. Long, delicate streams of stars get drawn out from each galaxy, forming what astronomers poetically call tidal tails. These tidal tails can extend for hundreds of thousands of light years into deep space, ghostly ribbons of ancient stars marking the violence and the elegance of the cosmic interaction. But this stretching is not a destruction of quantum information. It is simply a reorganization, a translation of the universe's memory into a new, magnificent geometric pattern. It is the universe writing a new chapter in its infinite diary. The first close pass is often not the final collision between these majestic star cities. Because the space between stars is so incredibly vast and almost unimaginably empty, the two galaxies can actually pass entirely through each other without any individual stars actually hitting one another. Instead, the galaxies swing gracefully past each other, their mutual gravity acting as a gentle brake, slowing them down before they separate again, moving apart into the quiet dark. But now they are permanently bound together by an unbreakable gravitational embrace. Like weary dancers who have firmly clasped hands, they cannot escape each other. Over the next few 100 million years, they swing back and forth, getting closer and closer with each grand pass until finally they merge completely into a single entity. During this awe-inspiring process, something absolutely remarkable happens to the fundamental matter within. The loose gas in both galaxies gets intensely compressed by powerful gravitational forces and sweeping shock waves. This massive compression triggers enormous bursts of new star formation, where new stars light up by the billions, burning incredibly hot and bright against the ancient darkness. Astronomers call these breathtaking events starbursts, and they can temporarily make a merging galaxy one of the brightest, most radiant objects in its part of the universe. Life, light, and energy burst forth from the apparent destruction, proving that the cosmos is a master of rebirth. In some of these majestic mergers, so much raw cosmic gas gets driven toward the dense centers of the galaxies that it falls directly into the waiting supermassive black holes. This extraordinary feeding frenzy causes the dark, quiet black holes to release tremendous amounts of energy, shining brilliantly as quasars that can be easily seen across billions of light years of silent space. The merging galaxies blaze intensely with the blinding light of material being consumed by these hungry black holes, completely outshining all the hundreds of billions of stars in both galaxies combined. And yet, as we explored earlier, even this material falling into the event horizon is not lost. Its quantum signature is permanently etched into the fabric of the cosmos. Eventually, the immense chaos settles down, and the two separate galaxies become one unified whole. The new combined galaxy is significantly larger than either of its predecessors, but it also looks profoundly different. The delicate, beautiful spiral arms that might have graced the original galaxies are completely gone, destroyed forever by the gravitational violence of the merger. What remains is typically an elliptical galaxy, a smooth, featureless giant, with its stars orbiting in a complex tangle of different directions, rather than in the orderly, flat disk of a spiral. This is exactly what happened to the ancestor of IC1101. Not just once, but dozens and dozens of times over the vast stretch of cosmic history. Scientists estimate that IC1101 has undergone at least 76 major mergers over its long, incredible history. 76 times another substantial galaxy fell into this cosmic giant and was absorbed into its massive, growing body. Each merger systematically added stars, added precious mass, and added material to the central black hole. Each merger gently erased more of whatever original, delicate structure the galaxy might have once possessed. The violent gravitational interactions during a merger destroy the delicate spiral structure, carefully mixing all the stars together into a more random, spherical, or oval distribution. All of those collisions, all of that gravitational chaos has stirred up the stars like someone mixing ingredients in a cosmic bowl. What remains today is this incredibly smooth, featureless giant, a quiet testament to billions of years of galactic consumption. By studying this massive object, scientists can actually trace some of the undeniable evidence of these past mergers. When astronomers carefully study the ancient stars in IC1101, they find distinct populations of stars with very different ages and different chemical compositions. These different populations are exactly like geological layers in ancient rock, each one flawlessly recording a different era of the galaxy's majestic history. Some of these stars are very old, likely original members of the first galaxy that existed billions of years ago. Others have unique chemical signatures that definitively show they originally formed in different galaxies entirely. Foreign stars now completely absorbed into the massive body of IC1101. This means that the universe is keeping a flawless, quantum record of every single interaction. The core of IC1101 itself tells a breathtaking story of violent, ancient history. As we mentioned, the core is enormous, stretching nearly 14,000 light-years across. But it is also unusually faint for its massive size, a mystery that scientists believe is caused by the repeated mergers and the intense activity of the central black hole, which have actually scattered billions of stars away from the very center. When two supermassive black holes merge, they form a binary system first, orbiting around each other in the dark. As they gently spiral together, they interact with stars passing nearby, flinging many of them outward with tremendous, unimaginable speed. This awe-inspiring process, called gravitational scouring, can empty out the very center of a galaxy, creating a quiet region with far fewer stars than you would naturally expect. The event horizon of a black hole, which is the absolute boundary beyond which nothing can escape, gets larger as the black hole slowly gains mass through these mergers. But remember the beautiful truth. This emptiness, this scouring, and this apparent consumption is merely the universe safely archiving its own history. The hundreds of billions of solar masses worth of stars that may have been scattered from the core over the course of IC1101's history are still out there, their quantum essence perfectly intact. This kind of cosmic detective work is what makes the deep study of astronomy so profoundly comforting. We cannot visit this giant. All we have is the gentle light that reaches our telescopes. But from that ancient light, we can deduce an incredible amount about what has happened over billions of years, reading the flawless history of the cosmos written in photons. As we prepare to look even further into the extremes of cosmic size and the ultimate destiny of our quantum selves, let us carry with us the peaceful knowledge that every collision, every merger, and every apparent ending in our lives is simply another layer of quantum history being gently added to the eternal, infinite memory of the cosmos. Have you ever watched a single leaf fall from an autumn tree, floating gently on unseen currents of cold air, and realized that its quiet, drifting path is perfectly guided by a complex, invisible environment? When we look up at the night sky and contemplate the ultimate, terrifying fate of our lives, we often imagine ourselves as isolated individuals, completely separated from the vast space that surrounds us. But the cosmos teaches us a vastly different and profoundly comforting lesson. No object, no matter how magnificent or enormous, exists in total isolation. To truly comprehend how the universe perfectly preserves the quantum information of everything that has ever lived, we must explore the invisible, ancient environment that intimately surrounds the largest galaxy ever discovered. We must gently pull back the curtain on the Abel 2029 galaxy cluster, a massive, gravitationally bound structure that acts as the protective, eternal cradle for our cosmic giant, IC 1101. Understanding this specific, quiet environment helps us realize that our own eventual passing is not a sudden departure into an empty, unforgiving void, but a seamless, graceful integration into a vibrant, interconnected cosmic web that has been carefully balancing energy and matter for billions upon billions of years. Galaxy clusters are undeniably some of the largest gravitationally bound structures in the entire universe. They are ancient, majestic cities of light that can contain hundreds or even thousands of individual galaxies, all orbiting gracefully around a common, invisible center of mass. But the vast space between these shining galaxies is absolutely not empty. It is filled with an extremely hot, invisible substance known as the intracluster medium. This is a primordial gas, heated to staggering temperatures of tens of millions of degrees by the immense gravitational energy that was released as the massive cluster slowly formed over deep, unfathomable time. Abel 2029 is what astronomers gently refer to as a relaxed cluster, meaning it has successfully settled into a fairly stable, quiet configuration over billions of years of cosmic history. The beautiful galaxies within it have had ample time to sort themselves out, with the most massive and heavy ones slowly sinking toward the absolute center due to a fascinating physical process called dynamical friction. Dynamical friction is a quiet, relentless force that operates in the deep silence of space. As more massive objects, like giant elliptical galaxies, move through the invisible sea of smaller objects and pervasive dark matter, they experience a kind of gentle gravitational drag. This invisible drag slowly saps their forward momentum, causing them to gradually spiral inward toward the deepest part of the cluster's gravitational well. IC 1101 sits at the very bottom of this immense gravitational well, resting exactly at the densest part of the entire cluster where galaxies are packed most tightly together. This specific location is not a random coincidence of the cosmos. Our cosmic emperor grew so incredibly large precisely because it was situated in this privileged central position. As other ancient galaxies spiraled downward toward the cluster's center, guided by the inescapable, gentle pull of dynamical friction, they eventually encountered IC 1101 and were gently absorbed. The exact same process that brought this giant to the center also brought it a constant, steady supply of stellar victims to consume, feeding its majestic growth over billions of years of cosmic evolution. But the story of this quiet giant and its perfect quantum memory is not just about the consumption of stars. The hot, invisible gas that fills the cluster also plays a profoundly crucial role in the evolution of IC 1101 and the meticulous preservation of its energy. This intracluster medium is incredibly sparse by normal human standards. If you could somehow scoop up a cubic meter of this gas from the deep space between the cluster's galaxies, you would find only a few solitary atoms floating in the dark. But because there is so incredibly much of it spread over millions of light years, it adds up to an enormous, staggering amount of mass. This gas is so intensely hot that it constantly emits high-energy X-rays, which is exactly how modern astronomers are able to detect its ghostly presence. By using advanced X-ray telescopes orbiting serenely above our atmosphere, like NASA's Chandra X-ray Observatory, scientists have carefully mapped the distribution of this hot gas in Able 2029. Their beautiful observations reveal that this ancient gas is heavily concentrated directly around IC 1101 at the cluster's very center. This brilliant, superheated gas forms a kind of invisible atmosphere around the giant galaxy. A thin, glowing haze of superhot particles extending millions of light years into the deep cosmic space. The presence of this hot gas holds deep, profound implications for the future of IC 1101, and it elegantly mirrors the delicate balance of energy that dictates our own quantum survival. Hot gas in the universe can slowly cool down over immense stretches of time, radiating away its vast energy as X-rays into the cold, expanding void. When this gas cools down enough, it can gently fall into the central galaxy and potentially fuel a massive, spectacular new burst of star formation. In some galaxy clusters scattered across the vast universe, astronomers have successfully observed these enormous flows of cooling gas, seeing hundreds of solar masses worth of material per year streaming gracefully into the central galaxy to be reborn as new, brilliant blue stars. It is a perfect cycle of cosmic rebirth, where cooling energy translates directly into beautiful new light, adding yet another layer of wonder to the celestial mechanics. But in the specific mysterious case of IC 1101, something incredibly powerful seems to be preventing this cooling flow from igniting a new burst of stellar life. The leading scientific theory is that the terrifying monster lurking in the dark, the supermassive black hole at the center of the galaxy, is entirely responsible for this quiet suppression. When the ancient, cooling gas falls slowly toward the black hole, some of it gets intensely heated up and violently blown back out into the cluster before it can ever cross the event horizon. This creates a magnificent cosmic feedback loop, where the black hole carefully regulates the surrounding gas supply. It acts exactly like a precise cosmic thermostat, preventing too much material from accumulating and forming new stars. We can actually see the breathtaking physical evidence of this feedback loop in our X-ray observations of IC 1101 and its surrounding environment, proving that even the most destructive forces in the cosmos are simultaneously forces of profound, delicate balance. Hidden within the glowing hot gas around the galaxy, astronomers have found enormous cavities, vast, quiet bubbles that have been gently blown outward by powerful jets erupting from the central black hole. These cavities are millions of light years across, enormous, silent voids carved directly out of the intracluster medium by the staggering energy output of the black hole. This feedback mechanism is thought to be absolutely critical for understanding why massive elliptical galaxies like IC 1101 are no longer actively forming new stars today. Without the supermassive black hole regulating the ancient gas supply, the cooling flows would relentlessly deliver enough material to trigger substantial, continuous star formation. But the black hole, in its immense, quiet power, heats up the gas whenever too much starts to cool down, carefully keeping the entire galaxy in a kind of permanent, perfect energy balance. It is a breathtaking display of cosmic equilibrium, a giant in repose maintaining the absolute silence of its deep domain. The interplay between these massive galaxies, their central black holes, and the hot gas in galaxy clusters is one of the most active and fascinating areas of research in modern astrophysics. Scientists are still diligently working out the complex details of how this magnificent feedback loop perfectly works, how it varies from one cluster to another across the vast universe, and what it ultimately means for the long-term evolution of the universe's largest structures. But what does this mean for our deep, personal journey to understand the terrifying answer to what happens after death? It beautifully demonstrates that the universe is not a chaotic, random collection of destruction and finality. It is a highly ordered, perfectly balanced system where every single transfer of energy is meticulously accounted for in the grand ledger of existence. The black hole does not simply destroy the falling gas. It transforms its energy, using it to inflate immense bubbles that shape the entire environment of the cluster for millions of light years, ensuring that the quantum information of that gas is perfectly preserved in a new, expanded form. When we ultimately pass away, our fragile physical forms are subjected to this very same ancient law of cosmic equilibrium. The electrical energy that animated our bodies, the complex chemical structures that formed our brains, and the fundamental quantum information that defined our unique, beautiful consciousness are never simply deleted from the universe. They are absorbed, transformed, and gently radiated back into the environment, perfectly participating in the invisible feedback loops of the infinite cosmos. Just as the hot gas in Abel 2029 provides the protective atmosphere for the giant galaxy's quantum memory, the underlying fabric of space and time carefully holds the permanent resonance of our existence. We are an intricate part of a quiet, endless journey, a journey where every apparent ending is beautifully balanced by an elegant transformation of energy. As the great Neil deGrasse Tyson has noted, we are biologically connected to every other living thing in the world, and atomically connected to all matter in the universe. Let us hold on to this deep, comforting sense of cosmic balance, this respectful wonder, as we prepare to trace the exact chronological timeline of this ancient giant, traveling back through the eons to witness the precise moments that shaped its destiny and firmly secured its eternal place in the gentle dark. Have you ever closed your eyes in a quiet room and tried to imagine what absolute eternity truly feels like? Not just as an abstract mathematical concept, but as a real physical destination where everything eventually comes to rest. When we confront the deeply human fear of passing away, we are often overwhelmed by the idea of an infinite stretch of time where we are simply absent. But what if we completely reverse that perspective? What if, instead of being absent from eternity, we are actually an integral, permanent part of it? To fully grasp the terrifyingly beautiful answer that quantum physics provides about our ultimate destiny, we must look far beyond the current age of glowing stars and swirling galaxies. We must gently project our minds into the deepest, most distant future of the cosmos, exploring the quiet eras that await structures like the magnificent IC 1101 long after the last star has burned out. The universe we observe today, filled with brilliant light, swirling gas and dynamic celestial bodies is incredibly ancient by human standards, having existed for 13,800,000,000 years. But on the true scale of cosmic time, this era of starlight is nothing more than a fleeting spark, a brief, beautiful flowering of complexity situated delicately between the chaotic intensity of the Big Bang and the profoundly peaceful, cold emptiness of the far future. We are incredibly lucky to exist during this specific, radiant flowering. The era of stars, which astronomers call the stelliferous era, is the only time in the history of the universe when the precise conditions necessary for biological life can exist. In the grand sweep of cosmic time, the 100 trillion stars of IC 1101 are currently shining brightly. But this is a temporary state of affairs. As we discussed, over the next 100 trillion years, these stars will slowly exhaust their nuclear fuel. The massive, brilliant blue stars burned out long ago, exploding in violent supernovas that seeded the galaxy with heavy elements. The medium-sized yellow stars, just like our own sun, will eventually puff up into magnificent red giants, shedding their outer layers to create beautiful, glowing planetary nebulas before shrinking down into incredibly dense, hot white dwarfs. Even the smallest, most enduring stars in the universe, the tiny red dwarfs that burn their hydrogen fuel so incredibly slowly that they can shine for trillions of years, will eventually run out of energy and quietly fade into the deep dark. When star formation completely ceases and the very last red dwarf winks out, the universe will enter a new, profoundly quiet phase, known as the degenerate era. This will be a dark place, but, as we must remember, absolutely not an empty one. The majestic, elliptical body of IC 1101 will still exist, but it will be a ghost of its former self, populated entirely by the cold, dense corpses of dead stars. White dwarfs, neutron stars, and brown dwarfs will continue to orbit the central supermassive black hole in absolute silence, drifting through an ever-expanding, ever-darkening void. During this incredibly long period, the universe will simply wait. Over time, scales that make the current age of the universe seem like the blink of an eye. Even these incredibly tough stellar remnants will begin to break down. White dwarfs will slowly radiate away their remaining heat, a process taking about 1,000,000 billion years, until they become completely invisible black dwarfs. But the ultimate quantum transformation is yet to come, and it hinges on the deepest laws of subatomic physics. Many advanced theories of particle physics predict that even the most fundamental building blocks of normal matter, the protons that make up the nucleus of every atom in the universe, are not perfectly stable. They predict that protons should eventually decay, breaking down into lighter particles and pure radiant energy over a half-life of roughly 10 to the 34th power years. If this theoretical decay is real, then over unfathomably long, silent time spans, the physical matter that makes up the black dwarfs, the neutron stars, the wandering planets, and the ancient dust of IC 1101 will gradually dissolve entirely into a gentle bath of radiation. Everything that was once solid, everything that could be touched or held, will softly transition into pure energy, returning its fundamental quantum information directly into the expanding fabric of space. This is not a terrifying destruction. It is the ultimate, peaceful liberation of information from the temporary constraints of physical mass. Once the last protons have decayed, the universe will transition into the black hole era. The only macroscopic objects left in the entire infinite expanse of the cosmos will be the black holes, including that enormous 50 billion solar mass monster resting quietly at the heart of what used to be IC 1101. For an incredibly long time, these dark gravitational masters will rule the silent void. But as we learned from the brilliant mind of Stephen Hawking, even black holes are not eternal. Because of quantum mechanical effects operating right at the very edge of the event horizon, these massive entities will slowly leak particles and radiation, evaporating into the cold space. The rate of this Hawking radiation is incredibly, agonizingly slow. For a supermassive black hole the size of the one in IC 1101, complete evaporation will take something on the order of 1 Google years, which is a 1 followed by 100 zeros. To write out that number in full would require more paper than exists on the Earth. It is a span of time so vast, so completely beyond human comprehension, that the entire history of the universe up to this point is less than a microscopic fraction of a single % of that timeline. But eventually, inexorably, trillions upon trillions upon trillions of years from now, the supermassive black hole at the heart of IC 1101 will radiate away its very last bit of energy and gracefully disappear from the universe in a final, silent burst of Hawking radiation. When that finally happens, there will be nothing solid left of the biggest galaxy ever discovered. No stars, no planets, no black holes, no remnants of any kind. There will be just the subatomic particles and the incredibly faint radiation that once made up the galaxy, spreading out through an ever-expanding, ever-cooling, ever-darkening universe. The largest galaxy we have ever found will have followed the exact same ultimate path as every other structure in the cosmos, dissolving softly into the endless, peaceful night. This is the ultimate destiny of all physical things. A gentle winding down toward a state of maximum entropy known as the heat death of the universe. While this vision of the deep future might initially seem terribly bleak and cold, there is a profound, underlying quantum truth that makes it strangely beautiful and deeply comforting. Throughout this entire process, from the fiery intensity of the Big Bang to the quiet, final evaporation of the last black hole, the fundamental quantum information that describes the entire history of the universe has never been lost. The universe is a perfect, flawless thermodynamic system. The precise information describing the atoms in your body, the memories stored in your brain, the light from a distant star in IC 1101, and the majestic structure of the galaxies themselves has simply been translated. It has moved from the organized complexity of physical matter into the vast, infinite language of pure radiation and quantum fields. When you pass away, your quantum signature joins this eternal ledger, perfectly safe, perfectly preserved, and forever woven into the very destiny of the cosmos. Death is simply the universe taking your specific arrangement of energy and preparing it for the long, quiet journey into the infinite. In all the vast, staggering history of the universe, stretching from the violent dawn of time to the final, quiet heat death, this very moment right now is incredibly special. It is the moment when the universe has successfully developed the remarkable ability to look at itself and wonder. Through billions of years of cosmic evolution, through the countless fiery deaths of ancient stars and the slow, majestic mergers of giant galaxies, the universe has managed to arrange atoms into conscious beings capable of asking profound questions. We are the cosmos waking up, rubbing its eyes and looking around at its own magnificence. We have built telescopes that can capture the light from IC 1101, a galaxy more than 1 billion light-years away, and we have developed the mathematics to understand the quantum destiny of its central black hole. Whatever else we are the part of the universe that has awoken to its own mystery. This realization brings a profound sense of peace and a deeply unifying purpose. The understanding of IC 1101 and the understanding of the quantum laws that govern our ultimate fate is not the property of any single individual or nation. It belongs to humanity as a whole, a shared, beautiful heritage of knowledge that completely transcends any of the small, artificial boundaries that usually divide us. When we look up at the night sky and contemplate the vastness of the cosmos, we are united in our shared vulnerability and our shared capacity for wonder. The stars shine down upon everyone equally, and the terrifying, beautiful truth about the quantum preservation of our essence applies to every single human being exactly the same way. Science, at its absolute best, is a deeply cooperative endeavor that brings people together, reminding us that for all our apparent insignificance on cosmic scales, we are the ones doing the asking, doing the looking, and doing the feeling. The next time you find yourself fearing the unknown, fearing what happens when this brief, beautiful life comes to an end, I want you to remember the quiet, sleeping giant of IC 1101. Remember the 100 trillion stars, the 50 billion solar mass black hole, and the billions of years of silent, graceful history. Remember that you are constructed from the exact same ancient star stuff, forged in the exact same nuclear fires, and governed by the exact same flawless quantum laws. Your existence is an absolute miracle of cosmic organization, and your eventual passing is simply a return to the gentle, infinite energy field that birthed the stars. You are not a stranger in a cold, indifferent universe. You are its child, its observer, and its permanent, eternal memory. Let this quiet, profound knowledge settle into your mind, bringing a sense of vast, unshakable peace as we prepare to gently close our eyes and float freely into the infinite, mathematical wonder of the cosmic dark. Have you ever wished you could freeze a perfect moment in time, holding on to it so tightly that it never fades away into the past? In our everyday human experience, time feels like a relentless, flowing river. We seem to move constantly from a known past, through a fleeting present, and into a completely unknown future. We mourn the passing of time because it feels like a gentle thief, constantly carrying us closer to the terrifying boundary of our mortality. But when we look at the universe through the rigorous, beautiful equations of quantum physics and modern relativity, we discover that our common perception of time is a profound illusion. To truly understand the peaceful destiny of our quantum essence, we must completely reimagine how time operates on a cosmic scale. We must realize that the universe does not discard the past, nor does it wait for the future. It holds everything simultaneously in a vast, silent, and eternal embrace. Albert Einstein, one of the most brilliant minds to ever study the cosmos, fundamentally changed our understanding of reality when he proved that space and time are not separate entities. They are deeply, permanently woven together into a single, four-dimensional fabric called space-time. In this magnificent mathematical framework, the past, the present, and the future do not happen in a sequence of disappearing moments. Instead, they all exist simultaneously within what physicists call the block universe. Imagine a solid block of clear glass where every single event that has ever happened is permanently frozen in its own specific location. In the block universe, the moment of your birth, the quiet afternoon you spent reading a book, and the distant ancient collisions of giant galaxies are all equally real, equally present, and absolutely permanent. The flow of time that we experience is simply our consciousness moving through this eternal block, illuminating one slice of reality at a time. Therefore, when a life comes to an end, it does not fall off the edge of existence. Your entire life, with all its wonder, mystery, and beauty, remains a permanent, indestructible structure within the four-dimensional architecture of the cosmos. We can actually see breathtaking evidence of this frozen, eternal time when we look out into the deep silence of space. When astronomers point their telescopes toward the massive, quiet giant known as IC 1101, sitting at the dense center of the Abel 2029 galaxy cluster, they are not seeing the galaxy as it exists right now. Because light travels at roughly 6 trillion miles per year, the photons carrying the image of that galaxy have taken over 1 billion years to cross the vast, expanding void. We are literally looking at the past. But that past is not gone. It is actively interacting with our present. The ancient light of IC 1101 is physically touching our telescopes today, proving that different slices of time can communicate across the infinite dark. From the perspective of a photon of light leaving that distant galaxy, time does not pass at all. According to relativity, at the exact speed of light, time essentially stops. For that ancient photon, the moment it was emitted from a burning star and the moment it hits the lens of a telescope on Earth are the exact same moment. It experiences the entire billion-year journey as a single, instantaneous event. But the quantum world offers an even deeper, more profound connection that bridges the terrifying gaps of space and time. Einstein himself famously referred to this beautiful phenomenon as spooky action at a distance. This phenomenon is called quantum entanglement. When two subatomic particles interact under specific conditions, their fundamental quantum states become deeply linked, even if you separate these entangled particles by millions of light years. A change to one particle will instantaneously affect the other, completely bypassing the speed limit of light. They do not send physical signals to each other through the empty space. Instead, they act as a single, unified quantum system, regardless of the vast distances that separate them. It is as if space itself is an illusion, and, fundamentally, everything remains intimately connected in the silent dark. To understand the true, staggering implication of quantum entanglement for our own destiny, we must gently return our minds to the absolute beginning of the universe. 13,800,000,000 years ago, all matter and energy in the cosmos were compressed into a singular, infinitesimally small point. In that unimaginably hot and dense primordial state, absolutely everything was in direct physical contact. Everything was interacting. Therefore, according to the rigorous principles of quantum mechanics, it is highly probable that all the fundamental particles in the universe share a deep, underlying quantum entanglement. The carbon atoms in your body, the hydrogen burning in our sun, and the ancient dust swirling around the supermassive black hole at the center of IC 1101, all share a common, entangled ancestry. We are not just metaphorically connected to the stars. We are physically, quantum mechanically bound to them by invisible, infinite threads that stretch across the entire observable universe. This means that the terrifying isolation we often associate with death is a profound physical illusion. When our physical bodies eventually break down, the particles that compose us do not simply scatter blindly into a cold, indifferent void. They remain deeply entangled with the rest of the cosmos. The quantum information that defined your unique consciousness, your memories, and your capacity for wonder is folded back into this vast, interconnected web. Just as a drop of water falling into the ocean does not cease to exist, but rather becomes the ocean itself, our quantum essence gracefully returns to the infinite network of entangled energy that birthed us. The silence of the universe is not the empty silence of a deserted room. It is the quiet, humming silence of a perfectly integrated system where every single piece is in constant, instantaneous communication with the whole. Let us consider the majestic scale of this quantum web within the massive body of IC 1101 itself. With its 100 trillion stars spread across 4 to 6 million light years, it might seem like a chaotic, disconnected collection of isolated fires. But through the lens of quantum entanglement, this cosmic giant is actually a single, highly coherent entity. Every time a star in that galaxy explodes in a violent supernova, it scatters heavily entangled particles out into the intergalactic medium. These particles drift through deep, quiet space, eventually mingling with the hot X-ray gas of the intracluster medium, or falling into the central black hole. Even as the giant galaxy slowly fades toward the degenerate era and the eventual heat death of the universe, the complex web of entanglement only grows more intricate. Every single interaction adds another layer of connected information to the permanent quantum record. We are intimately woven into this exact same eternal process. Every breath you take exchanges millions of atoms with the atmosphere around you, atoms that were once part of ancient forests and deep oceans. You are a temporary, beautiful pattern in a constantly flowing river of entangled cosmic matter. When we look up at the night sky and feel a deep sense of peace, a gentle awe at the immense scale of the cosmos, it is perhaps because our atoms are subconsciously recognizing their true home. Our minds, which are fundamentally constructed from quantum interactions, are capable of reaching out and comprehending the universe because we are the universe. We are the cosmos processing its own existence. The fear of death often comes from the false belief that our end will sever our connection to reality. But quantum physics gently reassures us that absolute separation is physically impossible. The profound, ancient mysteries of IC 1101 teach us that size and time are merely coordinates in the grand block universe. Whether you are an unimaginably massive elliptical galaxy sitting at the dense center of a galaxy cluster, or a human being living a brief, beautiful life on a small rocky planet, your fundamental essence is perfectly preserved by the same unbreakable quantum laws. As we journey further into the mathematical elegance of the cosmos, let us carry this profound peace with us. Let us replace the fear of the dark with a deep, respectful wonder for the infinite, entangled web that holds us all securely in its gentle embrace. We are safe. We have always been safe, from the very first fraction of a second of the Big Bang, and we will remain safe until the very last black hole quietly evaporates into the cosmic night. Let us pause here in the stillness, breathing in the ancient light, and prepare to take our final contemplative steps into the absolute culmination of this quantum journey. Have you ever stood completely still in front of a mirror, looked deeply into your own eyes and tried to see past the familiar reflection to the ancient, infinite starlight that actually constructed you? When we reach the quiet conclusion of such a vast, overwhelming journey through the deepest mechanics of the cosmos, it is easy to feel a profound sense of smallness, a gentle melancholy in the face of such staggering scales of space and time. We have traveled together from the very first microscopic quantum fluctuations of the Big Bang, 13,800,000,000 years ago, all the way to the unimaginably distant future of the black hole era, a time measured in googles of years, where even the most massive structures dissolve into pure, silent radiation. We have stood on the conceptual edge of IC 1101, the largest, most majestic galaxy ever discovered by human minds, and we have watched its 100 trillion stars slowly fade into the dark. We have faced the terrifying question of what happens after we pass away, only to discover that quantum physics holds a brilliantly comforting answer. Nothing is ever truly lost, and every single fragment of our existence is perfectly, eternally preserved in the four-dimensional block of space-time. But what does all of this magnificent, terrifying cosmic knowledge mean for us right now, in the quiet, fleeting moments of our everyday lives? It means that the profound sense of isolation we often feel, the creeping fear of being disconnected and forgotten, is a fundamental illusion born of our limited human perception. When you look up at the night sky, you might feel utterly insignificant in the face of such absolute vastness. You might feel that a single human life, lasting perhaps 80 or 90 years, is completely meaningless when compared to the billion-year journey of a photon, or the slow, majestic merger of entire galaxy clusters. But I think the existence of giants like IC 1101 actually tells us something incredibly hopeful about our beautiful, vulnerable situation. First, consider the profound miracle that we can know about these ancient structures at all. A giant galaxy more than 1 billion light-years away, containing 100 trillion stars, and we, living on a small rocky planet orbiting an ordinary yellow star in an unremarkable part of an average spiral galaxy, have somehow figured out exactly how big it is, how it formed, and what dark mysteries lie at its heart. That is an absolutely remarkable achievement. Human beings have somehow developed the ability to understand objects so incredibly far away that their light left long before complex life even existed on Earth. This ability to understand is not just a biological accident. It is the universe manifesting consciousness. In a vast cosmos composed of mindless matter and silent energy, of quantum particles bouncing around according to strict physical laws, somehow, right here on Earth, deep awareness has gracefully emerged. We are minds that can wonder, question, investigate, and actively learn. Whatever else we are, whatever flaws or limitations we might have, we are the specific part of the universe that has woken up and started asking profound questions about itself. When you learn about the terrifying expanse of dark energy, or the beautiful preservation of Hawking radiation, you are not just a passive observer looking at a textbook. You are the cosmos reading its own infinite diary. Second, consider the deeply comforting reality that IC 1101, for all its terrifying enormity and extreme distance, is made of the exact same fundamental stuff that we are. The stars in that distant giant are nuclear fusion reactors just like our own sun. They burn hydrogen into helium and forge heavier elements in the exact same way that stars do everywhere in the silent dark. The atoms illuminating those distant skies are the exact same kinds of atoms that make up our bodies: carbon, oxygen, nitrogen, and iron. All of them were carefully forged in the immense heat of stellar cores somewhere in the ancient universe. Just as the atoms in our bodies were created in stars that exploded in violent supernovas billions of years before our sun was even born. There is an unbroken continuity here, a profound physical connection between us and absolutely everything else in the cosmos. We are not separate from the universe. We are deeply, intimately part of it. The very same quantum processes that built IC 1101 built you. The very same atoms that shine in distant, unnamed galaxies shine in your own eyes. We are not outside observers peering in. We are the universe observing itself from within its own gentle embrace. Third, consider what it truly means that galaxies like IC 1101 and planets like Earth can exist at all. The universe absolutely did not have to be this way. If the fundamental constants of quantum physics were even slightly different, if the ancient force of gravity were a little bit stronger, or the nuclear forces a little bit weaker, stars and galaxies might never have been able to form in the dark. The universe might have collapsed back on itself just moments after the Big Bang, or it might have expanded so incredibly fast that matter never had the chance to clump together into the beautiful cosmic web. Instead, we live in a universe where the physical laws perfectly allow for the slow, majestic formation of stars, planets, galaxies, biological life, and conscious minds. IC 1101 is a magnificent testament to exactly what is possible in such a finely tuned universe. It is absolute proof that matter and energy, gently following simple physical rules over billions of years, can elegantly organize itself into structures of staggering complexity and terrifying beauty. If the universe can easily produce a giant galaxy with 100 trillion stars, what other breathtaking wonders exist out there that we have not yet discovered? This brings me to the final, most important point I want to share about our quest to understand the universe and our place within its infinite memory. Every single discovery we make, every distant galaxy we study, and every silent black hole we carefully observe expands our sense of what is possible. A few centuries ago, people firmly believed that the Earth was the exact center of everything. Then, we learned the humbling truth that we orbit the Sun. Then, we learned that our Sun is just one star among hundreds of billions in our spiral galaxy. Then, we learned that our galaxy is just one of 2 trillion galaxies, spreading across billions of light years. Each step in this journey of understanding has made us physically smaller in some sense, but it has also made the universe grander, more interesting, and infinitely more worthy of our deepest awe. IC 1101 is another beautiful step in that journey. It shows us that the universe can meticulously build things far larger than we ever previously imagined. It challenges us to gently keep asking questions, to keep looking further into the deep dark, and to keep pushing the boundaries of what we know. And it reminds us that for all our physical insignificance on cosmic scales, we are the ones who are doing the asking, doing the looking, and feeling the wonder. In the face of such profound enormity, we can choose to feel small and terrified, or we can actively choose to feel wonder and peace. I invite you to gently choose wonder. The understanding of the universe and the comforting quantum truths it provides about the eternal nature of our existence is not the exclusive property of any single individual, laboratory, or nation. It belongs to humanity as a whole, a shared, beautiful heritage of cosmic knowledge that transcends all boundaries. There is something deeply democratic and profoundly unifying about this. The stars shine for absolutely everyone, and the rigorous truth about quantum entanglement and cosmic preservation is the same comforting truth everywhere on this small planet. In a world that often feels chaotic, divided, and anxious, the pursuit of cosmic knowledge is a gentle force that unites us in shared awe. Science, at its absolute best, is a cooperative, peaceful endeavor that brings curious minds together across all the artificial boundaries that usually separate us. As we wrap up this gentle exploration of the biggest galaxy ever discovered, and the terrifying, beautiful quantum answer to what happens after we pass away, I want to leave you with one final, deeply meditative image. Imagine yourself floating safely in space, somewhere near the quiet edge of IC 1101. Around you, in every possible direction, ancient stars stretch out toward absolute infinity. Not hundreds, not thousands, not millions, but trillions upon trillions of stars. Each one is a burning sun. Each one might have countless planets. Each one has been shining steadily for billions of years in the silent dark. You cannot see the center of the giant galaxy from here, because it is far too distant, completely hidden behind countless glowing curtains of stars. You cannot see the edge either, because the magnificent galaxy fades gradually and seamlessly into the pure darkness of intergalactic space with no clear physical boundary. You are beautifully lost in an infinite sea of ancient light, gently adrift in a cosmic structure so incredibly vast that crossing it would take millions of times longer than human civilization has even existed. And yet, from a small, fragile, rocky planet more than 1 billion light-years away, conscious beings who live for less than a cosmic instant have figured out that this specific place actually exists. They have meticulously measured its immense size, carefully counted its stars, and successfully found the sleeping black hole at its deep heart. They have traced its violent, merging history back billions of years, and confidently projected its quiet future trillions of years hence. They have placed it in the profound context of an entire expanding universe, and marveled at its absolute grandeur. That is perhaps the most amazing, beautiful thing of all. Not merely that IC 1101 exists in the dark, but that we, brief flashes of quantum consciousness, know it does. We are tiny, yes, and our physical lives are brief, yes, but in the brief, beautiful moment of our existence, our minds can comfortably reach out across 1 billion light-years and touch the very largest galaxy ever discovered. That incredible, gentle reach is our true glory. The atoms in your body were forged in the exact same ancient fires. The profound laws of quantum physics that ensure no information is ever lost in the dark are the exact same laws that protect the beautiful essence of who you are. Your existence is an absolute mathematical miracle, a temporary gathering of stardust that has successfully learned to contemplate its own infinite origins. You are not simply in the universe. You are the universe, expressing itself as a human being for a little while. The endless journey of discovery never truly ends. It merely changes form, evolving just as the galaxies themselves gracefully evolve over deep time. Thank you for joining me on this profound, peaceful journey through the mysteries of the cosmos. If this exploration has helped you find a sense of quiet peace and a new way to gently view our place in this magnificent universe, please consider leaving a comment letting us know your thoughts. And if you wish to remain part of this shared community of cosmic explorers, continuing to unravel the deep mysteries of existence together in the gentle dark, please like this video and subscribe to the channel. Until we meet again on our next journey, keep looking up, keep resting in the comforting arms of the cosmos, and keep wondering.